Howdy again. It's tubalcain, and this time with machine shop tips number 283, entitled Cutting a Woodruff Keyseat on the Atlas Lathe, and this is by the economy method, meaning it does not require a milling machine and it does not require a milling attachment. But first, just a couple of definitions here so that we get things straight. These are Woodruff keys, sometimes called half-moon keys, as opposed to the straight keys, which you sometimes see too. But the terms keyway and key seat are misused often, even by me, and I probably will later in this video, but I'll try not to. But this is the keyway in the pulley or the sprocket or whatever it is that you're keying to a shaft, and this is the key seat. In this case, half moon, and the Woodruff key fits into it like that, and it is necessary to cut those with Woodruff Keyseat cutters like this, and they come in many different sizes, and you must use the appropriate size for the key seat that you are cutting. I have in stock an ample supply, and I don't even know why I have so many selections here of Woodruff keys, and in some of these here there is no chart like there is here. I suppose those were lost sometime along the way, but I prefer these selections here where there are charts, and in some of the older ones it's going to tell you the sizes, even the price here. You can tell this is pretty old if a key was only 20 cents, but we have numbers there, WK and so on, and also the sizes, and you're going to see a similar thing here on a newer selection. Obviously this is newer. Look at the prices on those. Some of them are over $1, and these are available in both unplated, and I prefer the unplated. I just happen to think that they are closer to the right dimension. Sometimes they don't allow for the thickness of the plating, in my opinion. I may be wrong on that. And you can buy these at any hardware store, and here's a selection of them, also the Dorman selection. And I have a selection here of key seat cutters, but you can buy them individually from any of the suppliers, and they are not too expensive, and they go both by diameter and thickness, and that must match the diameter and thickness that you see here on the chart. For instance, this particular one is 1/4 by 7/8, so you would need the appropriate cutter. The purpose of a key, of course, is to prevent a pulley or sprocket or device from slipping or spinning on a shaft. A set screw alone digging into a shaft is never sufficient. Even if it's on a flat spot, it's going to twist, so we use keys. And I explain some of that because I understand there might be some young people or some newbies watching, so that's the purpose of a key, whether it be Woodruff or straight. Now there are some other things that I have to tell you here, is that I'm going to put the keyway or the key seat into the 3/4 shaft, and I'll do aluminum and steel. And that Woodruff key formerly was called a number 11, but that may be a very old number. Now it's called a number 607, but if you go to the hardware store, it's probably by the size 3/16 by 7/8, and you can check that with a radius gauge like this, and you can see that the 7/8 fits right into that, like that. And you can look up dimensions in Machinery's Handbook and many other sources, or just find that information on the internet, but you will need some mathematical information here in order to do this. You may find some of this information very confusing, and so you need to read up on it if you do not understand it, and it is not explained very well in the Machinery's Handbook, although the numbers are all there. But we have to find the depth of the key seat. That is how deep we're going to cut for the key, and looking that up for a 3/4 shaft and that size key, it's going to be 279 thousandths deep, plus or minus a few thousandths, and that can vary just a little bit. And then we have to add the chordal depth to that for a total depth of 289. I think I'll probably call it 290.290. Now, what is the chordal depth? And that is the confusing part. The chordal depth is this distance between the top of the shaft and flat, where the distance here equals the distance of the cutter or the keyway. That can be found in charts, that information. It can be found using formulas. You're better off just using a chart, and there's yet one other way of doing that. Let me show you that, and it doesn't require mathematical computations. To illustrate what the chordal depth is, I cut that flat exactly 3/16 wide on the milling machine, 187.5 or something, but that's close enough. But that happens to be exactly 10 thousandths deep, and holding a radius gauge on there, if I were to measure that now with some kind of little feeler gauge or something, that would be 10 thousandths gap there. And we have to get that chordal depth. Now, in order to do that, you also can touch off and then mill it until it gets to be the right width there, but that isn't that easy to do because it's hard to see. But many people do it that way. They just touch off, mill until they get the right width, and then go ahead and feed it in. There's my other dimension here. The rest of the dimension, 0.279 from there. So you can do it either way. And I think probably what I told you seemed very confusing. Go back and watch it again. I was catching up on my winter reading, and I ran across this article in an old Popular Science or Mechanics by W Woodson here, and he's probably long dead. This is probably from the late 40s, but he shows how to cut this Woodruff Keyseat on a lathe with a little homemade fixture. Now, I made one of those fixtures real quickly. It's cheap and easy to make, and it works fine on the Atlas Lathe. It may not work for you on a Logan lathe, so it might have to be 12 inches or up. So let's step over to the lathe, and I'll show you what I came up with. In the next video, I will show you how to cut the keyway using the Atlas milling attachment. But those are expensive, hard to come by, and probably few of you have them, and this is the poor man's way of doing it. And all this required was a block of steel, and this is a 1/2 inch thick, but it could be 5/8, maybe even 3/4, but there's not a whole lot of clearance in here. And I drilled 2 holes, and you will have to have a separate fixture like this for each different size of shaft that you may need to hold in there. So this has been reamed 3/4, and there's a hole here that is, I believe, 9/16. So let me take that off and show you how I made that. This is a T-slot nut that came off of this, so it fits perfectly, and it's a 9/16 fine thread. And this is a hardened bolt, and the spacer here was just so that I didn't have to cut the hardened bolt off. Here's the reamed hole, slit, and then there's a hole drilled through here, clearance as far as the slot, and then threaded a portion of this, and that is a 5/16 fine, and we cannot have too much distance here. That has to be a minimum amount so that the back of this doesn't hit up against the thread protector here. So you can't make it too oversized. These other dimensions can vary. This is not that rigid. It cannot be compared to a milling machine, and you have to take light cuts, but it will do in a pinch. So let me go ahead and get that mounted again. Now, there's several ways of doing this. One is to have the compound here perpendicular, and that's the method I'm going to use. And to prevent this from chattering or possibly moving, it may be necessary to tighten up one of the gibs. In other words, we want this locked. This can also be set at 90 degrees so the crank is out here to do the locating. I prefer to do it this way and then use an indicator, which I will show you here momentarily. So let me put this back on, and then I want to talk about how to hold the cutter. I'm holding my Woodruff cutter in a collet, a 1/2-inch collet. That holds it rather securely so it can't move in and out. You absolutely cannot hold it in a 3-jaw chuck or a drill chuck. And the reason for that is that these jaws are hardened and this is hardened, and those jaws just will not bite in or grip this. So avoid that. It can move on you. I'm not saying that it will for sure. The other thing is to use a cutter holder like this made for the milling machine. This is the wrong size. This is a 3/8, you need a 1/2. But the problem with that is that they employ a set screw, and the set screw again will not bite into a hardened shaft unless you have shanks, I should say, shanks that are have a flat spot like this, which I think we call the Weldon shank. But none of my Woodruff cutters have a flat on them, so this will not do, and a collet is the preferred method. The length of shaft that you can deal with is limited by the interference down here, and it could be longer than this. I think I can do about 10 or 12 inches, but this is just a sample piece. That's aluminum, 3/4 already clamped in there, tightened very securely. Now there's another dimension that we need here besides the depth of the key seat, and that is the set over. In other words, we want the keyway to be on the exact center line of the shaft. So in order to calculate that for a 3/4 shaft, the radius of the shaft is 375, and the thickness of the cutter, remember, is 3/16, so half of that is 94 thousandths. Add the two together, and it's 469 thousandths set over from after touch off, or when I touch the work with the cutter. Then I will move it over, and I'm going to use a dial indicator to find that, but you could use the compound if you've set it in the 90-degree direction as well. Now, since there really isn't any vertical adjustment with this at all, you have to locate where you're going to put the key seat with some layout lines, and then locate it up and down here, the vertical position, where you want it, and then tighten it here. So there is no fine adjustment. You just have to go according to a layout and eyeball it in as close as you can get it. I'm just using a strip of paper here, which is about 2 thousandths thick, as my feeler gauge, and I prefer to do this without the machine running, but you can just come up until you get a chip, and that's your Touchoff. But I'm going to bring this, advance the carriage now just a little bit until it drags. So I'm 2 thousandths away from the edge. Now I'll crank this in so it clears, and I'm going to set up the indicator and show you how I'm going to move that over now. A total of 469. I'm going to add 2 thousandths, so I'll go about 471. Using a magnetic base indicator with a long range, this is a 1-inch range, right on to the flat bed here. Now you may have a different distance here. You can cut this off. I just decided not to cut it off. It doesn't really matter as long as it doesn't interfere with anything. And with the indicator zeroed out, I'm going to move it 471 thousandths, and that's in this direction. 1, 2, 3, 4. There we go. Since the cutter is revolving in this direction, and that's in forward on this lathe. The chips may come up this way toward you, so wear a face shield or a goggle to protect yourself. And there's several ways to touch off now. One is to turn the machine on and slowly advance it until you get your first shavings, and then zero out the cross feed. And the other is to put tape on there or put paper between there, or just rotate the spindle by hand until you see it touch. So, you know, choose your own weapon on that. And then we will zero out the cross feed, and you will recall then I will feed in, or in this case I'm actually feeding out 289 thousandths, and be sure and write those dimensions down and have them handy. Don't try to carry them in your head. Alright, I'm going to touch off. There, I got some tiny chips, and I will zero out the dial on the cross feed. Now I'm ready to start cutting. Here we go. That's 80,000 so far. That's 100,000, so I'm 1/3 of the way there. This is just a little kerosene I'm using for fluid. That's 200 thousandths. Now don't feed too fast, because you can break the cutter off right at the neck. That's the weak spot. And don't get your brush caught in there. Make sure your safety glasses are on. And there we are. 290 thousandths. I'll clean it up and take it out of there. Be careful when cutting now. Remember, if you cut too fast or you do not have your work secure, that it can the cutter can break off right here. That'll at the neck. That'll be the weak spot. So be careful. Probably not with aluminum. Now there was very little burr on that key seat. This is the one I cut the other day. This is the one I did just now. And again, I know I'm repeating myself, but the plated one doesn't quite fit in. So I like the unplated, but suit yourself on that. These look pretty in the package. I think that's why it's done. And they should rock a little bit like that. They should be free enough to do that, and to slide your pulley or whatever it is right on as such. And that would be ready to tighten down. What I didn't mention yet in the video is that what size key do you use? Well, there's several different sizes that, for instance, that you could use on a 3/4. You can look that up in the Machinery's Handbook and it'll tell you what size to use, but you're probably going to be repairing something where you already know what the size is, or you have a blueprint or a drawing to go by. So that's how to do it in aluminum. You can proof yourself also with by checking this dimension here, and you'll find that also in a handbook, but to me the proof is in the pudding. Now I'm going to cut the key seat in 3/4 mild steel. The setup is already made. I've touched off. I failed to mention in the last segment that you absolutely must lock the carriage. You don't want that to move on you. Be sure and use some cutting oil. It is a nice sharp cutter. I do expect a little chatter and vibration as I get in deeper. See what I mean? Also note that there's not a whole lot of clearance in here, so if you make one of these little fixtures, you need to determine your own dimensions. And you don't want any more of the cutter sticking out of the collet than necessary. That's 150 thousandths deep. If you feel it vibrate, dwell a moment. There we are. Now here's the alternate method. I'm not actually going to cut a key seat on this, just tell you how to do it. Instead of using the dial indicator to locate your set over, set that off to the side. I told you that you could turn the compound at 90 degrees, and I already have, and we could touch off here as we did before and advance the compound in this direction, the correct amount. Now this is going to be an interference here, so naturally this needs to be cut off. You could trim it here, or actually it only needs to be about that long to start with. I'm not going to do that, but I'm just telling you that this is the alternate way of doing it. Again, you may have to, or you must lock the carriage when you do that. I like to cover the screw here too to keep chips from getting in there. So that's just another way of doing it, because there's more than one way to skin a cat. This is the key seat that I just cut in steel. Very little burr. Cut real nicely. I'm going to say that you probably will have to limit the width of your key seat that you're going to cut in by this poor man's method to a 1/4 inch maximum. And there's a good fit. And that's how you cut a key seat on the Atlas Lathe by the poor man's method, the economy method. Hope you enjoyed that and can maybe put it to use in your own shop. And be sure and watch the next video where I'll do a similar operation using the milling attachment on the Atlas Craftsman lathe. Hope you enjoyed the video. This is tubalcain saying so long for now, and I'll see you in my next video.